Good afternoon. My name is Navjal, Application Engineer with Ally PLM Solution. I would like to welcome you on this installment of Live Lunchbyte series. This series is designed to briefly explore capabilities of Solid Edge, which are often overlooked. Today's topic is sheet metal. As far as the agenda is concerned, we'll be modeling a part with respect to assembly. We'll talk about corner treatments. We'll talk about flat pattern options. And in the end, we'll flatten imported sheet metal part. So first of all, what we're going to do is we'll model a part with respect to assembly. So I have this assembly, and in the assembly I already have one part here, so I'll in place activate, so that part is just a blank part, and it's a sheet metal part. So what we're going to do here is we'll model a sheet metal cover on this pulley on the right hand side. So for that, what I need to do is put a sketch on the top, because we are in synchronous mode, no tab. So again, I can just plug in the dimensions and place a sketch on top. Now, since I already defined the gauge, you'll see that it automatically takes that gauge value, that is 1.98 millimeter. So in order to get flanges out from the sides, what I need to do is I'll just I'll press Control tab and then select all the different thickness faces. And now by clicking on the arrow, I can quickly create flanges. I'm not sure about the extent, so what I'm going to do is just use this extent point to define the extent for the flanges. Now, there's some visible interference on the top face that is coming from the pulley in the background. So what I'm going to do is I'm going to model a small dimple on the top, so that can take care of the interference. Now, with the help of dimple command, I can just select the face, the region here, and then specify the height of the dimple. In this case, I'm going to just enter 8 millimeters. Now, I don't need my base reference plane now. As far as the dimensioning is concerned, what I'm going to do is just hide the background assembly, and now rotate the part a little bit and show you some dimensions. Now, as far as smart dimension is concerned, when I select smart dimension, select the edge, it's going to a dimension from the outside of the edge. And similarly, sorry, picked the wrong edge, so I can just place it here. Now, similarly, what I can do is, if I want a dimension from the inside edge, what I can do is just select the inside edge and now place it here. All right. So if I want to modify what I can do is I can select the dimension and enter the exact value here, which in this case is 175. And since my live rules are on, that will take care of the background face, so it matches. So what I'm going to do is just rotate a little bit in order to see how this matches with my assembly. So I can show. I'm going to show my background assembly here. And now, as you can see, that there is a lot of interference here, interference with the pulley, with the frame, with the spring. So in order to take care of that, what I'm going to do is just use a jog command. The jog command is located inside the bend, the drop down. So all I need to do is just sketch a line, select the line, and then give it a direction. Now, notice the position of my cursor right now. I can just enter whatever value I want to here. So if I keep my cursor on the background assembly, and you'll see that it tries to snap all the time, and I've seen a lot of time it gives us a small alert that it cannot place or something like that. So it's always better if you know what's your extent going to be. It's always a good practice to keep your cursor on the white space, so that you can define the extent without snapping into any point, any background point of the assembly. So in this case, it's going to be 25 millimeters. Now what I'm going to do is rotate this face a little bit. So I just grab the face. Now I can orient the axis of the steering wheel. In this case, I don't want any coplanar faces to be selected, so I can check my coplanar live rule option off, and now I'm all set to rotate it. So the rotation angle, I'm going to keep this as 40, and I'm going to repeat this operation on another face. The only difference is I will just change the angle instead of 40 to 20. Now, so what we did, we just change the normal faces. What about the thickness face? Is there a way I can rotate this thickness face? Whenever I select the thickness face, I get 2 arrows. Again, I can drop down flanges. So what about how to rotate the thickness face? What you can do is, if you click on the origin, you can place it at the corner. And now, if you click on the steering wheel, you're able to rotate this thickness face. In this case, I'm just going to click somewhere, not worry about dimensions. Now, as far as the top view is concerned, I don't like the way this bend is coming off here, so I'm going to remove some material here. Again, I just select the sketch and the plane. So in this case, I'll just create a closed sketch. And now with the help of my control key, I can do multiple select on my vision and define the extent of material removal. So I'm not, since there's already material Solid Edge knows, so what I can do is just define the extent and it will automatically remove the material from the part. So that took care of the corner issue which I had. So what I'm going to do is just rotate this part a little bit so that I can change some of the definitions on the other side. So right now, as you can see that the part, there are 2 bolts. So what I want to do is I want to bolt this part with the help of those bolts. So I need some flanges. So what I'll do is I'll just grab the face, hit Control key for multiple select, and grab another face. And with the help of arrow, I can just drag another flange here. So now, since there is no cutout definition here, so first thing what I'm going to do is just define a cutout on so that it can be bolted. So I can use quick pick, or I can select the edge, so and place a small hole on that particular bolt. All right. So on the other side, on the right hand side, what I want to do is I want to taper the face that is a normal face. I want to put some taper angle before I move the face to the bolted. So for that, what I'm going to do is just place a small dimension here and then give it a value. In this case, I'm going to enter 40, and then I want to lock this down. You'll see the reason why I want to lock this down, because I don't want this to change when I change the angle of this face. So in this case, what I'll do is I'll just select multiple face so that it this face on the left hand side, it also comes around with the taper angle. So what I'm going to do is I don't want any coplanar faces, so for that purpose I just turn my labels off. So now I can define the angle of my rotation, and you'll see that it took care of the other side flanges. Now we're all set. Now we'll just repeat this another step here to get this bolted cutout here, and then put a small hole. All right. I don't like the way this corner is on the left hand side because it's kind of open. I want to close this down, but I also want to leave some gap. So for that purpose, what I'm going to do is just select this face. Depending, since there is an angle on this face, so when I try to get a flange, you'll see this flange is going inside. So maybe that's not what I want. So what you can do is you can create relationship between faces. So it's not called relationship, but it's called relate face command. So how to get that command? So what you can do is just select the face, and then with the help of quick bar, you can select relate, and then you have different options. I'm sure you worked on relationships on sketches. In this case, what I'm going to do is there are a lot of options like perpendicular, concentric, rigid, ground. So in this case, I want to do it at coincident. And then I want to make that left-hand highlighted face coincident with the one which is highlighting now that is on the right-hand side. So all I have to do is just select these 2 faces and do coincident face. As you can see that it lines up with the face on the right. So now these 2 faces are coincident. Now the next thing what I'm going to do is just match these 2 together, flush them together, but I don't want, I want a gap of 1 millimeter between them. So how to get that gap? What I can do is just click on Shift key on my keyboard and then click on the primary axis. So in this case, my gap is going to be 1 millimeter. So I'll just enter 1 millimeter and then place it, and then I can click on the primary axis and select this edge that is on the bottom left corner. So right now my gap is 1 millimeter, as you can see here. So maybe I want to increase that later on. I can increase it. So I can select the face, move the face with the help of the steering wheel. But in this case, what I'm going to do is just put a dimension because I know it's going to be 2 millimeters. So I can change the direction whichever way I want to. So in this case, I just want to enter 2. So now you'll see that the gap it changes from 1 millimeter to the other one, to 2 millimeters. Now the next thing what I'm going to do is just click this face and make this face coincident. Again, I go to a roulette face and select this face. I want this face to be coincident. All right, so part looks good. Now one thing which I want to do on the top is edit profile feature. Now we're working in asynchronous. Now if I want to edit the profile of this dimple, what I can do is select the dimple and then I can click on edit profile. In this case, what I can do is say I want a polygon by center. So I can select the center point and then get a 6-face hexagon. So I don't want the circle, so I can use my trim commands to get rid of the circle here and this one, the outer circle. So it's all set. What I can do is just come out of the edit profile command, and that will give us a new feature that is a hexagonal feature, by changing the profile of that feature. So we all set. So I'll just go back to our top level assembly, show the part, respect to assembly. So this is how our part looks like. Now, just a quick visual inspection. If I turn this part a little bit on the right-hand side, you'll see that there is no interference. The pulley interference taken care of. The part is very well bolted to the base part. All right, the next part of the session will cover corner treatments inside of Solid Edge synchronous environment. So what I'll do is I'll just select the template, and then I don't want to be redundant, but I need a sketch, so I'll just sketch with the help of rectangle by center command. I'm just going to enter the quick values. So oftentimes I forgot to define the thickness, like the gauge. So I can define the gauge afterwards. Inside properties, material table, I can specify the gauge, and that will change the thickness value from 1 millimeter. That is the default value in ISO template. So now what I can do is, as you've seen in my last activity, what I did, I clicked on my control key for multiple select. In this case, what I'm going to do is use selection manager. So how to get some of the selection manager? There are 2-3 ways, but the easiest way is inside the select drop down, there is a tab for selection manager mode. So what it does is it changes the selection mode to selection manager, and I can click on the face, and that comes up with a dialog box. So I want to select a face that is parallel to this face. So I can select the face command, and you'll see that it highlights the parallel face. In this case, I want to select this face and make it parallel faces. All right. So now, in order to come out of this mode, what I can do is there are 2 ways. Either I can uncheck this or use Shift and space bar. So as a shortcut, I'm going to use Shift and space bar, and that will highlight. Let me use this one more time. Change back to selection mode, and now I can select the face on the other side and this side. And after come out again, I do Shift space bar. Now it will turn into a flange. Now what I need to do is just select the arrow in order to get the flange to work. Now, with the help of my tab, I can switch between these two dimensions. Now, if I want 90 degree, well and good. If I want to change, I can change, and again hit tab, and that takes us to the extend step. Again, if I want to change it back to 90, I can just hit tab and type in the exact value. So in this activity, we're going to talk about corner treatment. So I'll just go into my ISO view and then highlight this corner. Now, first of all, where is this command located? Two bend corners. So what I want to do is close the two bend corners here. So I select that command, then I get an option here, quick bar, and it's asking me to select these two bends. And then it comes up with a value that says gap value, right? So there are two options in this quick bar. One is called a closed corner. The other one is called overlapping corner. So what are these values? We'll talk in detail about these values. First of all, let's see what is this gap value. So right now it says 0, and I can see that my selection here is closed corner. So looks like these two faces are kind of joined in the middle. So because the gap value is 0. So if I change the gap value to 0.5, as you can see that all the thickness, these two thickness faces are dropping back. That is 0.5 millimeter. So maybe this is what I want, maybe not. So my first impression here was, what is this gap value? How is the system calculating this gap value? So what I'm going to do is just, for that purpose, what I'm going to do is just create a sketch on this plane. And then I want to zoom into this plane and sketch a line between this and this. So remember, our closed corner treatment value right now is 0.5, right? So I would dimension this line, and my first opinion was this has to be 0.5. So when I put the dimension, it was 0.7, it was not 0.5. So what is this gap value? So the gap value is the distance between these two planar faces, the perpendicular distance. In order to get that value, what I'm going to do is just select this line and this plane and drop the dimension here. And that value says 0.5. Right? So that's the actual gap value, and that's not something that it's not the point-to-point distance between two flanges. So now if I change, you'll notice a change in both of these values. So if I change from 0.5 to 0.75, you'll see that the one on the top, it gives some different value than at the bottom. So that's the actual gap value. So notice if I change it back to 0, these two values will be coincident, because at that point these two the edges are kind of on the same point. So at this point, what I'm going to do is change back from close corner to overlap, and then talk about what is this overlapping corner. So remember, our gap value selected 0. So at this point, if I change to overlapping corner, it will give me two options. So first option is overlap ratio, the other one is gap. So the meaning of gap is same, it's taking the same value which we took. So if I say 0.5, it's going to do the same thing, but this overlap is something different. So that's the difference between close corner and overlap. So it's a ratio, it's not any dimension. So what it does is, if you right now it says 0, that means these two planes are coincident, they're lying on the same plane. So maybe that's what I want, maybe not. So if I want to make change, say I want to modify it to 0.5, I can change it to modify, and you will see that this thickness face is now at 50%, like 0.5 times this length. So if I want to change it to 3/4, I can just say 0.75. You'll see this moving. Actually, I changed my gap value instead of overlap ratio. So now I'm going to change my overlap to 3/4, 0.75, and you'll see it coming up. So if I change back to 1, you'll see that this face is kind of flush with the other face, or it's coincident, lying on the same plane. So that's the meaning of overlap. We just covered overlap ratio, gap values, right? So at this time, what we're going to do is we'll go into some other corner treatments. So I'll just select a different corner for that. So in ST3, there are some new corner treatments that were introduced, and those treatments were, if it's like these treatments were a U corner, V-shaped corner, all this. So what I'm going to do is first talk about U-shaped cutout. So if I select this U-shaped cutout, you'll see that my dialog box changes and gives me a bunch of values, and it gives me a bunch of values, and you'll see a small display here depending upon the values. So at this point, what I'm going to do is enter some values here. So I want to change this overlap to 0.5 and change the diameter to, and also the gap values from 0 to 0.5, diameter to 5, and give it an offset of 15. And you'll see that as I'm changing it, it dynamically previews the corner. All right. So we covered overlap ratio and gap values. Now, what is diameter? Diameter is the circle here you see. Now that's at the end, and the offset value is the distance between the center of this diameter and the point where these two bends are connected. So if I want to change it, what I can do is I can just say, if I change the diameter, you'll see that change the diameter. Now, offset value, I can make it 20, and that will move the diameter towards the port. Right, at this point, I'm all set, and the shape is U, as you can see that. Now, in order to get a better view, what I'm going to do is just to create a quick flat pattern on this port and do a top view. Now, you'll see it's a U corner, and the diameter value is going to be the value which we entered. All right. So I'm going to switch back to port here. And the next corner treatment which I'm going to cover here is V corner treatment. There's not much difference between U and V. The only difference is the angle value. So what I'm going to do is just select these two corners, give it, select the treatment to V-shaped cutout, and now I'm going to enter some values here in order to define gap and diameter. So the only difference we will see at the bottom, it says angle. So that angle will define the shape of your V. So in this case, if I increase the angle from 15 to 30, you'll see that it moves downwards. So that's determining the shape of this V. In this case, if I say 45, it's moving the diameter. Again, we can make changes in the diameter and offset. It's very much like we did in U. So right now our angle is 45. If I go back to my flat pattern, you'll see on top view, you'll see that it's kind of the angle. I can just enter the angle values, that is 45. All right. So that's the difference between U and V. U has a 0-degree angle, while V has, you can enter whatever value you want to, the close corner. The last one which I'm going to cover here is called a square cutout. So what I'm going to do is just select this again, select this cutout command, and square cutout, select these two bands, enter a width. In this case, I'm going to enter 15 as width and offset as 10, and create a square. Again, just to get a better view, we can go back to our flattened state and see these values. And this value, since it's a square cutout and it values all the width and the length values are similar, so that's kind of difference between these different type of cutouts. You'll see the U cutout, V shape, square cutout. All right, the next portion which I'm going to cover here is some feature deformation, and in that section I will place a louver on the top face. So for that, what I need to do is we just use dimple here. I'll use louver. So when I select louver command, you'll see it dynamically previews the louver, and if I want to make changes in the dimension, I have to go to the options, and then I can change these options to 50. So I just divide it by 2, all these, and it kind of previews here. So now at this point, what I can do is, you'll see that it previews the axis where it is going to align. So with the help of shortcut keys like N and B, and you don't have to learn, you get feedback here at the bottom. So with the help of N, I can change the orientation of my louver. So right now it's attached to my cursor, and I can just press N on my keyboard for the orientation purpose. I can lock myself down to this top plane, and with the help of E on the keyboard, I can just enter dimensions. So I'm entering dimensions before placing. So in this case, I'm just going to say 40 and say 165. Place it. Now I'm going to make a pattern on this feature. For that, I just selected rectangular pattern. Now by default, you'll see that it gives me an alert, and the pattern kind of moves away from the part. If I want to change this orientation, all I need to do is just click change the x-axis orientation on the steering wheel. So if I change the orientation to down, you'll see that it kind of dots on, it comes back to the face. And due to the dimensions, I can change the dimensions, and now it's kind of on the face. So if I don't want to use dimension, what I can do is click on any instance, and then I can make sure that everything is covered. Now this x count and y count, what is my x and y direction? The direction of the primary axis is my x direction. So if I want to increase the count, I can just change from 3 to 5 and hit accept, and that way I can change the orientation, the number of occurrence. Now one thing I want to mention here is, let me save this part real quick. It's the new flat pattern treatments that were introduced in ST2, I guess. So what I'm going to do is I'm going to first we're going to look into some of the flat pattern treatments. So if I go into Solid Edge options, flat pattern treatments, there's an option here that says as deformed feature, right? So the formed feature display, like right now it's a louver, so it will display as formed feature. Maybe that's not what I want. So what I'm going to do is just create a quick drawing in order to display this formed feature. So if I create a drawing, in this case, since the file has a flat pattern, I have this option activated. I can just select the top face and drop that face here. So one thing to note here is the type of formed here, the louver that's coming up. So if I want to change this display, all I can do is just go back to our part, go to the options, flat pattern treatments, and change this back to as feature loops and feature origins. And you'll see what difference it makes in a little bit. So if I go back to my file, my drawing file, hit update, you'll see that in this stage, I get a punch point, that's the middle point, and I don't get that entire feature. So what I'm going to do is quickly dimension this part. So what I'm going to do is just select my coordinate dimension, and then select this punch point. And now I can change the axis to the other side. All right. So now I've dimensioned this to punch point, and all is good. Last but not least, what I'm going to show you is how to modify, how to bring in imported sheet metal data. So what I'm going to do is open a file that came from another CAD system. In this case, I'll just hit open. I'm going to bring this into our part template, not sheet metal template. For our purpose, I'll just show you a little bit. So what I'm going to do is this part is kind of little, it has some curves, a lot of flanges. So our first objective of this activity is to create a flat pattern of this data. So I did this in order. I can transition to order, and now you'll see that this part, we need to flatten this part. So first thing which I did, since I am inside my part template, so I have to transform it to sheet metal. So what I'll do is go back, go to my application tab, and then say transform to sheet metal. So when I do this, I get all I need to do is just select the face. It comes up with a message that it contains some cylinder or non-concentric faces. So what are these? In order to detect that, what I did, I just ran geometry inspector tool on this part, and you'll see that it came up with small faces, edges. So that was the reason why it was not converting into sheet metal. So So the approach which I took in order to convert this part into sheet metal and then flatten this was I just copied the top surface. Now there are different options. Whether you want to copy a single surface, I just highlight the chain one so that I want the top cover. Now at this time, this copied surface is kind of connected to the part copy. So in order to delete the part copy, the thickness, I just want the copy surface. What I can do is just drop the parent so there's no more talking to the part copy. So now I can delete the part copy, and all I have is an infinite small surface. So I want to add some thickness to this this face. So for that, what I did, I just click on Add and then Thicken command, and then selected the top surface and then enter a value. And this value would be the value of the gauge thickness value. I'm all done. Now I have the thickness, so let's transform this part to a sheet metal part. All I have to do is just select the face, and you'll see on the left hand side Pathfinder, Solid Edge converted all this face into flanges and create some features. Now I can just click on Tools, Flat Pattern, select the face and the edge, and I can flatten the part. All right, that's all I have for today. And as far as replays are concerned, you can watch this session as a replay on youtube.com/Ally PLM. And training, there's a bunch of training coming up next year. Fundamentals ST3, Fundamentals ST3 update, and all this information is on the website allyplm.com/training.asp. Thank you for your time. Here's our technical support information. Please email us or call us if you have any questions, concerns, confusions, comments, and we'll take. All right. Thank you very much. Merry Christmas and have a wonderful New Year. Thank you.